Global warming is destroying our planet.
Greenhouse gases such as carbon dioxide causes the planet to heat up and dry out.
Droughts cause wildfires all around the world, destroying entire ecosystems, like what happened in Australia last winter.
And here in Sweden during the last few summers, leaving the world with fewer trees and plants to help take up the large amount of carbon dioxide.
What can we do to help this?
We can replant and regrow.
Throughout history, there have been multiple inventions to make planting more efficient, starting with simple tools such as the gardening hoe, and later on the plow and the seed drill.
We took inspiration from these historical inventions to create our own solution for more efficient planting.
Our wind-powered seed drill can be part of the solution to prevent these destructive catastrophes.
Using wind power, we designed a device that could be used to plant seeds and trees.
It works by making a hole in the ground with a small drill, and then putting in a seed or sapling. It is mobile and completely wind-powered, which means it does not require access to electricity and it doesn't run on fossil fuel.
We came up with this idea during a 4DFrame national competition in Sweden called Enlightening Imagination. While using our creativity, we worked together to make a simple device,
inspired by some of the things we learned about at school.
We see our invention as a hybrid of the two most important inventions in history.
It represents a technological improvement of the original seed drill invented by Jethro Tull in the 1700s and the Dutch windmill.
Of course, tree planting machines and seed drills exist today, but they all have something bad in common.
They pollute because they run on fossil fuels.
Now you might be wondering how we made this model.
But wonder no more, because we are going to show you.
My name is Amelie.
And my name is Matilda.
And we're from Bilingual Montessori of Lund.
And in this video, we are going to show you how we built our wind-powered seed drill.
Step by step.
Let's start by making a propeller. Take a dodecapod and cut 6 cm long tubes in half. Attach 1/2 to every second peg of the dodecapod.
Add octopods to the ends. Then attach the second half of the tubes to that octopod. Attach another octopod at the end of those.
Now take 6 more 3 cm long tubes and add octopods to their ends. Then put them in the rest of the pegs of the dodecapod. Angle the blades to catch the wind.
Now test your invention by holding it up to a fan.
Now let's build the body using the frame of the circle parts. Take 4 6 cm long tubes and push them halfway through.
Now take 4 3 cm long tubes and push them into the remaining holes. Take 8 quadrupod connectors and add them to the tubes.
Now cut 1 cm long tubes to put the two halves together. Now take 6 7 cm long tubes and add them between the quadrupods to form a frame.
Attach 4 7 cm tubes to the outer quadrupods. To their ends, we add U-shaped connectors.
Take a 10 cm long piece and add a rubber stopper around the middle. Now take a 3 cm long tube and attach a question mark connector and a U-shaped connector to the ends. Slip on the U connector.
Now let's make a cogwheel. Cut 12 2.5 centimeter long tubes. Take a dodecapod and attach the tubes to every second peg. Add a cogwheel to the longer tube. Repeat this whole process twice. It was my first time participating in this contest. Was it yours?
No, it wasn't. I was in the contest last year too.
So what was the theme?
Well, the theme was like a moon exploration sort of thing. I honestly like this theme much better.
Yeah.
It's got more freedom, more different things you can do, more creative liberty. It was more fun.
Let's make the drill and the seed holder. For the drill, take an octopod connector and 3.5 centimeter long tubes. Add one tube to every peg and attach the other end of the tube to another octopod to form a cylinder-like shape.
Do the same thing for the seed holder, but use hexapods instead of octopods.
Take a 4.5 centimeter long tube and add a U-shaped connector to both ends.
Intertwine it with the 3 centimeter long pieces and keep them in place with a rubber stopper.
We take a 23 centimeter long tube and put the rubber stopper on one end and slip the 2 U-shaped connectors intertwined to increase stability.
Then attach another rubber stopper. Add 2 dodecapods with a 3 centimeter long tube attached to it. Repeat the process on the other side.
Add the drills and the seed holder to the ends of the cogwheels. Trim the tubes if necessary.
Now it's time to attach them to the framework. Simply lower it and attach the question mark connectors to the frame.
Now for the wheels. Take a dodecapod, cut 6 2 centimeter long tubes and attach them to every second peg of the dodecapod.
Put on the second biggest rubber circle. Trim the tubes to fit if necessary. Repeat this process 4 times. Keep them in place with 2 more rubber stoppers. Add 2 of the wheels to the ends. Repeat this process twice.
Adjust and attach the U-shaped connectors to the bottom of the main frame. Push the wheels in and trim the extra tubes.
Yeah, so in this year's 4DFrame Enlightening Imagination contest, we had the same kit as we had in the video.
Did you have the same kit last year?
No, it was a little bit different. We had fewer longer parts, I think. And the rules were a little different as well. Because this year our model had to fit in a cube that was 30 times 30 times 30 centimeters long. But last year it didn't have to do that. And this year the model also needed to work with a fan because it's a wind-powered theme. But last year there was no wind power, so it didn't have to work with a fan.
Oh, okay.
Now adjust the model and add tubes with question mark connectors at both ends to stabilize. Finish the model by adding the turbine. Okay, so what did you think was hardest?
We didn't have any big problems while building it, but it was hard because we had a limited time.
Yeah, the time.
So, and we were told to keep our sketch to the end of the time, so that was hard because we didn't have so much time to.
Yeah, we were doing the sketch, cleaning, and finishing the model.
Yeah,
all at once.
And the model stopped working in the end, so we had to like fix it in different ways because we had too much friction and different points.
Yeah, so
but we managed
adjust it
to do it in time. You know, it was also hard because we were so many people and sitting pretty close, so it's hard to not get distracted by the other groups. So, but yeah. What did you think made our prototype special?
I mean, the rule was that we had to have 2 moving parts interacting with each other. We technically have 3. So we have this part, and then we have these 2 that interact with the propeller, I guess you could call it. And then we have the wheels as well. And they're not really interacting, but they're still moving.
Yeah.
So, how did you feel using your acrylic nails when you were doing 4DFrame?
Yeah, it was in the beginning a challenge, but it was pretty easy to get used to, so it wasn't so much big of a problem.
Yeah.
So yeah.
No. Yeah, things aren't really that hard with long nails.
No. You get used to it easily.
Yeah.
So in the beginning when we built the propeller, it worked like normally, but throughout the competition it stopped working.
Yeah. Yeah, well, it was the more friction, the better the propeller had to be to move it. So, of course, we had to redo it a few times.
Yeah.
But it was just small adjustments, like just making sure the angle was right.
Mhm.
Yeah, and we have them different heights so that they can catch more wind.
Yeah.
And I think that helped.
Yeah, and we also put in these in the middle
Yeah.
of the blue ones.
The
So yeah.
octopus. So 4DFrame is like a material for active learning, like so that when you do something with your hands, you don't forget it, like when you just do a normal test. Do you think it works?
Yeah, I think so. I think it's a lot easier to learn when you think it's fun. And this is a way to make the lessons more fun, and I think more people will remember it after.
Yeah, maybe.
Before like tests and in class, we usually like study, but it feels like it's more like trying to memorize the different parts, and that is not the best way, for me at least, to learn. So I think, yeah, after like 2 days after the test, I could forget everything. So I think this is a better way to be able to learn it in a more fun way too. So like I can remember how I did this, like I'm repeating the whole process in this video.
Yeah, and that's kind of the point of sustainable learning. Yeah, I think it works, but I think the best thing is a sort of combination between studying things and actively making them happen. Because if you just build, you don't really learn the theory behind it. And if you just learn the theory, you don't really learn to build. So it's probably best to balance the two.
Yeah.
So, you want to tell them how we came up with this idea?
So basically, it was through an accident. So it was a mistake. These parts were supposed to be the same size from the beginning, but I just took the wrong part, and the one became smaller than the other.
Yeah, so they were both supposed to be drills from the beginning.
Yeah.
But then we made one smaller, and we decided to just go with it and make it a seed splitter instead.
Yeah.
Yeah, there are no accidents apparently.
Thanks so much for watching!
Goodbye.